The Big Rip is one of the most extreme theories for the universe's fate, suggesting that dark energy's repulsive force could keep increasing until it tears the cosmos apart. Unlike the gradual cooling of the Big Freeze, the Big Rip would be rapid, violent, and absolute, starting with galaxies pulling away from each other, followed by the destruction of stars, planets, and eventually atoms themselves. If dark energy keeps accelerating expansion, it could overpower gravity, electromagnetism, and even nuclear forces, unraveling all matter. Even black holes, normally expected to last trillions of years, would evaporate instantly. Current models predict that if the Big Rip is real, it could occur in as little as 22 billion years. But could an unknown force prevent this fate? Is the universe destined for total annihilation? Or is there still something we don't understand about the fabric of reality? True or false? In a Big Rip scenario, even the strong nuclear force that binds atomic nuclei together would eventually be overpowered. True. Which of the following scenarios would most likely lead to a Big Rip? Dark energy strengthens, accelerating expansion indefinitely. Fill in the blank. The Big Rip depends on whether dark energy continues to blank at an increasing rate. Strengthen. Fill in the blank. As galaxies are torn apart in the Big Rip, they would experience extreme blank forces, stretching them apart. Tidal forces. At what stage in cosmic evolution would the Big Rip affect black holes? After galaxies and planetary systems are torn apart. Fill in the blank. If the Big Rip is real, then the last objects to disintegrate before atoms would be blank. Black holes. True or false? The expansion of the universe due to dark energy is constant and does not accelerate over time. False observations indicate that the expansion of the universe is accelerating, which is why scientists are investigating whether the Big Rip is a possible outcome. Fill in the blank. The final phase of the Big Rip could break apart the very fabric of blank itself. Space-time. What distinguishes the Big Rip from the Big Freeze? The Big Rip destroys matter violently, while the Big Freeze gradually leads to heat death. Fill in the blank. The Big Rip assumes that the expansion of the universe follows a blank trajectory rather than slowing down or reversing. Accelerating. True or false? The Big Rip would occur in reverse order, destroying atoms first, then planets, and finally galaxies. False. The sequence of destruction in the Big Rip is predicted to start with large-scale structures like galaxies and then progress down to atomic and subatomic levels. Fill in the blank. If the Big Rip occurs, then after it finishes, the universe would contain only blank. Random quantum fluctuations. If dark energy follows a phantom energy model, what would be its ultimate effect on space-time? It would tear apart space-time itself, making distances meaningless. Fill in the blank. If dark energy were to change behavior and weaken, the universe might experience a blank instead of a Big Rip. Big Crunch. Fill in the blank. The first observational evidence that dark energy might cause a Big Rip comes from measurements of cosmic blank. Redshift. If the Big Rip occurs, could anything exist beyond it? If so, what might it be? If the Big Rip occurs, space-time itself would be destroyed, meaning all known matter, energy, and physical laws would cease to exist. However, some physicists speculate that quantum fluctuations, random energy disturbances, could persist, possibly leading to the creation of new particles or even a new universe. Some theories suggest that the destruction of space-time could trigger a cosmic reset, similar to how the Big Bang might have originated from a previous state. If the laws of physics re-emerge, the universe could be reborn with different properties, though it would be entirely unrecognizable. However, if the fabric of reality itself is erased, there may be no after at all, only a complete and final end. True or false? The strength of dark energy is constant and does not change over time. False. If dark energy remains constant, the universe would expand indefinitely, leading to a big freeze. However, in the Big Rip scenario, dark energy increases over time, accelerating expansion to destructive levels. Which of the following best describes the final moments of the Big Rip? Dark energy pulls apart all fundamental particles, destroying everything. Fill in the blank. The Big Rip is a theoretical scenario where the universe's expansion becomes so extreme that even blank cannot remain bound. Subatomic particles. If galaxies begin accelerating outward at 5,000 kilometers per second, and this acceleration doubles every 2 billion years, how long will it take for them to exceed the speed of light, 300,000 kilometers per second? To determine when galaxies will move faster than light, we use logarithmic calculations. The galaxy expansion rate starts at 5,000 kilometers per second and doubles every 2 billion years. Using logarithms, we find that it would take about 5.9 doubling periods to exceed the speed of light. Multiplying this by 2 billion years per doubling, we get a final time of 11.8 billion years before cosmic expansion becomes unstoppable. What key observation could help scientists determine whether the Big Rip is a likely outcome? Observing whether the rate of cosmic expansion is increasing. If a planet is 10 million light-years away, and the universe's expansion stretches this distance by 10% every billion years, how far will it be in 5 billion years? To calculate the distance of a planet affected by cosmic expansion, we apply 10% growth per billion years. After 5 billion years, the planet's distance increases to 16.1 million light-years, showing how rapidly space can stretch in a Big Rip scenario. True or false? If the Big Rip occurs, gravitationally bound structures like galaxies and solar systems would remain intact. False. The Big Rip predicts that even the strongest gravitationally bound systems, including galaxies, planetary systems, and eventually atoms, will be torn apart. Fill in the blank. One sign that the universe may be heading toward a Big Rip is that the expansion rate is blank over time. Increasing over time. If the Big Rip happens, what would be the last structures to be destroyed? Black holes. Fill in the blank. The force responsible for holding galaxies together against expansion is blank. Gravity. True or false? The Big Rip could cause space-time itself to be torn apart. Cool. Fill in the blank. If dark energy strengthens enough, even the very fabric of blank may be torn apart. Space-time. How does the Big Rip differ from the Big Freeze? The Big Rip destroys structures violently, while the Big Freeze slowly cools the universe. If the universe collapses from 100 billion light-years across to a singularity in 20 billion years, what is the average collapse speed in kilometers per second? To determine how fast galaxies will be moving apart after 20 billion years, we use the given acceleration rate of 500 kilometers per second per billion years. Since the expansion increases at a constant rate, we multiply 500 kilometers per second by 20 billion years. This results in a final speed of 10,000 kilometers per second. This calculation highlights how dark energy continuously accelerates the universe's expansion, making the vast distances between galaxies grow larger at an ever-increasing rate. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy friends.